Durreshehwar, right? I'm
Durreshehwar.
Okay, so we will first introduce ourselves quickly and then we will move forward with you. My name is Shatir Hasan. I'm a senior process engineer at EPC plant. Bernard is the CEO of Apple Vision. He's from Uganda. Shazar is also process engineer looking after the PVC units, PVC 1, 2, and 3. He's a process engineer. Zaeem is working in an oil refinery as a process engineer in technical services department. These are all our quick introductions. Now over to you. Introduce yourself, and we will move forward with the interview. Thank you.
From you, sir. I am Durreshehwar Zaeem from Chemical Engineering Department, final year student, and I have a CGPA of 3.59, and my final year project is about energy, exergy, economic and environment analysis of CO2 capture from natural gas using hybrid solvents. And using my skills of SPN, HYSYS, and Excels, till this point, I have performed the analysis of four solvents. And apart from my studies, I am a debater for 3 years, and I have using my communication skills, I have won various awards at different universities like Indus University and FAST University for MUNs and parliamentary debates. And I have also served as Director of Public Relations at an NGO named Falai Bashar, where I helped more than 30 families to gain poor families to gain financial assistance using my communication and judgment skills, whether they are needy or not. And currently, I am also serving as Secretary Parliamentary Debates at NED's Debating Society, where I train my juniors about communication skills and debates.
Yes, thank you for your brief introduction. Let's start with the questions related to S1 AIChE. Do you know where the Wilson fluid package is used for which components? You hear about Pang-Robinson equation of state, Chow-Steiner, and SRK. But what about Wilson? Do you know it? You can also share any idea or any guesses you have in your mind right now.
Sir, as far as I know, Wilson is not used for compounds of carbon and not organic compounds. It can be used for ionic compounds.
Just for your information, Tech is currently engaging for the free certifications. Have you applied for the free certification exam, which is of 4 hours?
I have not applied right now because I didn't know about this.
Okay, so from the last candidate, we have learned that you have already studied the petroleum refinery subject.
Yes, sir.
You guys, because you are all in the 8th semester. So, what's the difference between normal distillation and azeotropic distillation?
Normal distillation and isentropic distillation.
Azeotropic.
Azeotropic, sir. In azeotropic distillation, the components cannot be separated using a normal method that is based on the temperature difference or concentration difference. So what we have to do is we have to set the conditions of pressure difference, and then we can separate out components on the basis of pressure gradient instead of temperature or vapor pressure difference.
Okay, Bernard, over to you.
Thank you. How do you pronounce this name? Zaeem?
Zaeem.
Zaeem. Yes, Zaeem, I'm very glad to talk to you today. And I'm sure you're fasting.
Yes, sir.
Happy Ramadan.
Thank you, sir.
Yes, my name is Bernard. and I'm the CEO of Apple Vision Limited, an engineering and consulting company in Uganda. I've worked in the industry before I moved to the service industry. In your introduction, you talked about economic analysis, right?
Yes, sir.
That's so wonderful. From the engineering perspective, chemical engineers are given the skills, the knowledge to manage multi-billion engineering projects. Would you wish to manage one?
Yes, sir.
Hey, that's so grateful. Now, from an economic perspective, we carry out feasibility study to ascertain if an investment is viable or not. Have you read about chemical engineering economics?
Yes, sir. We have read about it. Will you repeat your question? Chemical.
Have you read about chemical engineering economics?
Yes, sir. We have read about it.
Oh, that's so great. Now, during appraisals, project appraisals, we use some economic concepts to ascertain if an engineering project is viable. Could you please tell us some of these concepts and what they are?
Sir, we will have to check the profitability index of the project to see whether the project will be profitable or not. And we have to check the NPV of the project to make sure that the project in which we are investing is right or not. And we also have to check the payback period of the project to know the investment that we are giving, in how much amount of time it will come back.
Well, let's go slow. I've heard about NPV.
Yes, sir.
The other one is?
Profitability index.
Profitability index.
Yes.
What are they? Would like to understand what these two concepts are.
Sir, NPV tells us about whether the project in which we are investing is right or not. That the answer of NPV tells us that if the NPV factor we get after calculation is positive, it means that our project is right for the investment. And if the answer is negative, it means that the project is not right for the investment. We will not get profit from it. We will get loss. And if it is zero, it means that the project will be break even. It means it will neither give us profit nor it will give us loss. And talking about profitability index, the profitability index should be greater than 1 if we want to have profitable project. And if it is less than 1, then we should not invest in that project because it will not give us profit.
That's so great. Now, the other question is about chemical engineering design. Have you done chemical engineering design?
Yes, sir.
What's the difference between process design and plant design?
Process design and plant design. Sir,
Yes.
in process design, we are only focusing on the process side of the plant. It means we are focusing on solely on the equipment side, like heat exchanger, distillation column. We are focusing on the designing of the equipments that will be useful in our process. Whereas in plant design, we are looking on overall plant, and it involves not only the process but also other sides like the welfare side or the environmental side, you can say, or the services that the company is providing. Like in process side, you will only have the distillation columns and equipments and all that. Whereas in plant design, you need to see the whole layout of the plant, that where will the project process location will be, and where will be the canteen will be, where will be the cafeteria, where will be the gym, where will be the medical center. In plant, you need to see all this, and where will be the utilities. You need to see all of this, that how you will be designing all the things that are required for the process to carry out, and how will you manage all the things that are required for the process. So in plant, you will also have utilities, and as well as from where will you get electricity, from where will you get the steam requirements. You need to see all of these things. Whereas in process design, you only need to see about that equipment designing.
That's so wonderful. Assuming you are working in the industry as a chemical engineer, and you're managing a process in which water and ethanol have been mixed. Remember, these two are miscible, right?
Water and ethanol.
Ethanol and water.
Okay.
How would you separate the two components?
Sir, we can use distillation to separate these components.
Why? Why do you use distillation? And how did it apply?
Sir, I'm saying distillation because the boiling point of ethanol and water is quite different. So we can use distillation because in distillation, the driving force of separation is boiling point or vapor pressure, you can say. So since ethanol and water have different boiling points, you can use distillation.
Okay. Now, well, this is the last one. Still under distillation, have you read about Murphy stage efficiency?
Sir, I didn't understand your question. How to?
Yes.
I didn't understand your question. How to?
Murphy stage efficiency or Murphy tray efficiency. Do you know what it is?
No, I'm not getting the word you are saying. How?
Murphy is M-U-R.
M-U-R.
P-H. R-double-E.
No, sir, I don't know this.
Murphy stage efficiency. In a distillation column, the efficiency that relates the theoretical plates to the actual plates.
So you are talking about efficiency of the distillation column.
Yes.
Efficiency of the plates, right?
Yes, yes. You get it now?
Yes, sir. Efficiency of the plates tells us about the ratio of ideal efficiency divided by actual efficiency. It tells us how much efficient will be our plates working.
Can the Murphy stage efficiency be more than 1?
If it is more than 1.
Yes. Can it be more than 1?
It means if it is more than 1, it means the distillation column is very efficient.
Okay, thank you. I've liked your confidence and the way you articulate. Back to you, Engineer Shaze.
Hi, Durreshehwar, this is Shazad. I just had a couple of questions. Can you hear me?
Yes, sir.
Okay. So point number one, you mentioned now that you have worked on a project with regards to carbon dioxide capture from the flue gases, right?
From natural gas.
Natural gases. Okay. So I had a couple of questions. One is what were the considerations that you had while you were selecting the solvent? And the other thing is, have you heard about the ionic liquids?
Yes. Sir, I will answer the second question first. I have heard about ionic liquids, but what we are doing here is that we need a solvent that can be applied industrially. So since ionic liquids are not available on commercial scale and they are very difficult to prepare, so we are not considering them. We are only considering solvents that can be easily applied in the industry. Ionic liquids are very difficult to prepare and are expensive to prepare. So we have dropped ionic liquids right now, and we are focusing. And about your first question, we are focusing on the solvents like MEA, that is chemical solvent, and physical solvents. And as I mentioned that we are working on hybrid solvents. So as we know that chemical solvents that are used right now in the industry have also limitations. They are energy intensive processes and they are very expensive and they are toxic and corrosive. So what we are doing is that we are preparing a hybrid solvent that will be a mixture of chemical and physical solvent, and that will be overcoming the limitations of the solvents that are used in the industry right now. So we will be comparing the results of our hybrid solvents with the solvents of the industry, and then we will perform the 4E's analysis. We will be comparing the results in terms of four terms. We will be seeing whether a process that is using hybrid solvents is more energy efficient and more exergy efficient, it is economic or not, and whether it is good for environment or not. If it is good for in these four aspects, we can say that the hybrid solvents that we are proposing can be applied in the industry.
Good. Good. We can like move on. If you have any further questions.
Do you have any questions?
Zaeem, do you have any questions in your bucket to ask? If you are there.
No, I don't have any question.
So Durreshehwar, just one little quick question as well. What is the perception? What is the perception in your mind with regards to process engineering, contact process engineering, and operations engineering? Just a general question.
So in process engineering, what I believe is that we will be looking forward on process side. That means that the reaction side or the systems where chemical reactions or chemical changes will be involved, like chemical reactions in chemical reactor side, distillation side, or you can say heat exchanger side. Whereas in operation side, there will be no chemical changes involved. In operation side, we will be looking forward on the separations that involve not chemical changes, just physical changes. Like I can simply say filtration, where it is only a physical change. So if we have a filtration system, that will be an operation side. Or I can say conveying system, the belt conveying system, it is also an operation side. And I can further say that if there is a sieving involved, it is also an operation side. So that's my perception. The things where no physical, no chemical or changes or chemical reactions are involved, it will be a operation side. Whereas the things where chemical changes will be involved, it will be process engineering side.
Okay, you will get to know once you'll head into your professional life, inshallah. But as Bernard said, that your confidence is like amazing, and you're quite outspoken from the very outset of this interview. And keep up this this very trait of you. And as you have been very articulate in your answers as well, and confidence is surely the key. And one thing that can be an improvement avenue from my side is on a longer run would be that you can take some time while answering the question, just a couple of minutes to think and sketch the boundaries of the answers. That will help you engage better with the other person. Apart from that, it's been a good interview.
Okay, sir. I have noted this improvement. Thank you, sir. May I leave now?
If you don't have any questions, then we can finish this interview with Zaeem. Zaeem, I will share the feedback with you after the interviews. Okay.
Durreshehwar will share the detailed feedback of this interview with you separately. Okay. If you want, you can just leave the conversation. All the very best ahead. Bye.
Thank you, sir. I have to share the feedback here or somewhere
We'll
else.